everyone, I'm Ravish Kumar, and today in this video, we are going to discuss one of the most interesting use case of machine learning, which is optical character recognition. So what does that mean by optical character recognition? So there will be some kind of image, and in that image, our machine learning model will try to find which characters are present in it. Okay, and for this particular video, we are going to develop one particular model, which is like handwritten digit recognition on MNIST dataset. Okay, so we will explain the problem in a greater detail and its direct use case with the current industry also. Okay, so let's move ahead. So what is character recognition? So character recognition, one of the interesting use case you might have found these days that at the traffic signals, police have installed the CCTV cameras. In those CCTVs, if traffic violators are there, so they will automatically detect the position of the number plate. Like suppose in any vehicle, the position of the number plate can be detected as a kind of bounding box. Bounding box means there will be a kind of box uh, which will be like enclosing the number plate of that vehicle. After that, there will be another model which will be creating a bounding box on each of the characters present in the number plate. Like suppose this is L, this is P, and a kind of tight bounding box will be drawn on each of the characters. Once that is done, these bounding box cropped images will be directly fed into a machine learning model which will detect which character it is, whether it is L, whether it is P. So these kind of predictions should be made by our machine learning model. But for our use case, what exactly we are going to develop in this particular video, we will be developing if suppose we have written any kind of a character like digits. Like suppose if this is a 5, we will crop this image and then feed it to our machine learning model, and that machine learning model will predict whether it is a 5 or 9 or anything. So the total number of classes that our model can predict in this particular model, in this particular case is like 10 classes, 0, 1, 2 till 9. So there are 10 classes, total of 10 classes. So this is the thing that we are going to develop in this particular video, one particular model. Okay. So let's quickly understand how exactly machines, which is a non-living thing, will start understanding the images. Okay. So machines don't see images as a kind of image. So it converts the image into a matrix form because machines can understand only the numbers. So in that case, machine will try to convert the image, whatever we will feed into our machines, into a matrix format, and that matrix will have a three dimensions. Three dimensions means so there will be a kind of matrix in the form of suppose x, comma y, comma z. So there are three dimensions, three coordinates will be there. Okay, this is a matrix with C. This is the first element of the matrix. This is the second element of the matrix, and this is the third element of the matrix. And these elements are nothing but the color channels that we have in our images. Okay, if you know, the images can be represented through the three color channels, which are red, green, and blue. These are the three color channels that are present in any of the images. So that's why we generally find images in the shape of suppose 224 cross 224 cross 3. So this is the size of the image matrix, or maybe any resolution that we want, like suppose 720 comma 720 comma 3. So this is the size of any kind of image that the machines understand. Okay, so now these are the colored images. In case of the character prediction thing that we are currently trying to build, we definitely do not want all the channels, all the color channels should be present there, right? We can solve, like as the number of channels will increase, the model complexity will also increase. How? So, so suppose how many elements in this image will be there? Like 224 cross 224 cross 3. If suppose we can definitely work with the black and white thing or gray thing, then why do we need all the information of the color channels? In that case, there will be a reduction of 2 by 224 into 224. We don't definitely do not want all the color channels. In that case, it will be just one gray channel only. So in that case, there will be a reduction of by like 3 times reductions in the total number of parameters that a machine learning model should learn. So we are definitely going to build a one channel. We are going to convert our image into a one channel image because our purpose or our requirement from this project is to detect the digits that are present in the image, and that can be easily done with the gray channel image as well. So let's see what kind of image we will be using for this particular video. So these are the images that will be present in our data set. Okay, so you can definitely see that this image corresponds to the label 3. We will have Definitely we are going to solve the supervised learning algorithm where we will be having some kind of data and corresponding labels as well. For this particular image, which is our data, image data, the corresponding label is 3. Okay. So we are going to develop a particular model which will be seeing this image and then giving me some kind of predicted value. What is exactly written in that particular image? Okay. Any confusion? So yeah. So first, let's understand image is definitely an unstructured data. Okay. Image is unstructured form of data. But can we think of any solution how we can store this unstructured form of data in the in a structured format? Like suppose we have an image of 28 by 28. Okay, 28 by 28 comma 3. So can we store this information, this much kind of information? How many information will be there? 28 cross 28 would be 784 into 3. 4 3s are 12, 8 3s are 24, 1 25, and 7 3s are 21, 2 23, 2 3. Yes, 2352 elements would be there. So can't we store these 2352 elements in the form of 1 cross 2352? Alright, definitely we can do, right? Like suppose in our case, what exactly we discussed, we are not going to use the 3 channels. So in that case, 28 cross 28 image will be there, definitely, right? Definitely, this is one gray channel, but cross one can be ignored, right? 28 by 28 is nothing but 784. We can definitely store all the 28 by 28 elements. Like suppose this is the structured format of data where we will be having some kind of feature values and number of samples will be stored in the rows. Like suppose image 1, image 2, image 3, something like that. If like suppose we have 10 images, then first image corresponds to this position, second image corresponds to this position, and third image corresponds to this position. But this position can't take a matrix format of 28 by 28. So in that case, what we can do, we can convert a 28 by 28 matrix. Like suppose this is the matrix, a 2 by 2 matrix, suppose A, B, C, and D. This is a 2 by 2 matrix. Can we also write it like A, B, C, D, right? So we can definitely write it in this way. So that's how a 28 by 28 matrix will be written in the form of 1 cross 784 numbers. 1 cross 784 numbers would be 784 features would be there in the data set, and one particular sample, one particular row will be representing one image. Okay, that one particular row corresponds to one image. So there will be however number of rows will be there, those many images will be present in our data set. Everything clear? So we are going to use MNIST a data set which is very popular in the field of handwritten digit recognition, and this data set can be easily found in the CSV format. CSV is nothing but a format in which we store the Excel sheet kind of thing. We store feature values in the columns, and then rows corresponds to the number of samples we have in the data set. Okay, so let's move ahead. So data normalization. How exactly data normalization helps in machine learning model formation? So if we note, there are two benefits of data normalization. First benefit is like it removes the bias towards those features which have very high value. High value means in our image also, we are going to use, or our machine will try to find the relationship between two different pixels, like the pixel 1 and pixel 2. Every pixel value, we know that image is 28 by 28, right? So these, every element will be called one pixel. And the possible values of these pixels are nothing but in the range of 0 to 255. 0 corresponds to the complete white image, sorry, complete black image, not white image. Complete black image, and 255 corresponds to the complete white image. Okay, so 0 corresponds to the complete black image and 255 corresponds to the complete white image. In that case, we will have multiple pixels in the 28 by 28 matrix, and these pixels value will be varying in the range of 0 to 255. But it might be a possibility that one particular pixel is like suppose 155, 145, and some second pixel is like 255. So our model should not be biased towards those values which have high magnitude value, these pixels. So that's why we need to convert, or we need to make sure that every feature, like we have 784 features, right? So we want to make sure that every pixel that is present in the image will lie in the range of 0 to 1. And it will ensure that our model is not biased towards any of the pixel values. Okay, so remove the biasness, which is definitely a kind of better thing. And then second benefit of normalization is like it streamlines the direction in which the parameters should be updated to reach the global minima of the cost function that we are going to we are intending to find. Like in by using our machine learning model, we want some kind of approach so that our parameters should give that kind of value for which the cost functions lies at the minimum, right? But if we do not if we suppose we are not normalizing our data, then it might be a kind of possibility that in for those features which are varying very heavily, or maybe suppose varying too much, so in that case update of the parameters will be required heavily also. So we definitely do not want our model to be going in one particular direction. Like every feature will have one dimension, right? Every feature will have one direction, and one dimension and one direction, you can definitely say. And suppose if our model is fluctuating very heavily in that direction because of the magnitude of like varying magnitude in that particular feature, so we definitely do not want our model to be fluctuating in that direction, and our model update like the parameters updations would be happening in a very streamlined manner so that it becomes easy for our model to find the global minima, which is our overall objective in our machine learning model. So these are the two benefits which will happen in the when we will normalize our data set. And one particular approach with this we are going to take for this particular case for the normalization is like we will directly divide everything by 255, because the maximum number we definitely know that it is 255, and if we will try to divide it by 255, every number will come into the range of 0 to 1. So this is the kind of data normalization technique that we are going to apply here. Okay, so let's learn about the, so after this there will be the complete data we will have. Okay, so once we will have the data, we will need to build the model. So let's learn about the model also. So this is the complete diagram which we are going to use. So we will be having some kind of image, like suppose this is a 28 by 28 image. So first we will flatten it. Definitely this needs to be converted into the form of 1 cross 784. 784 is nothing but 28 cross 28, right? And this 1 cross 784 will be like fed into the machine learning model, or machine learning where we are going to use the logistic regression model. Okay, so logistic regression model is nothing but a kind of form of linear regression model, but with the slight modifications to help linear regression to perform the classification problem. So logistic regression is a kind of advanced version of linear regression, you can say. Okay, so here we will be having some kind of weightage over all the features that we have. Like we have 784 features and definitely a bias also. And once that is done, it will try to predict 10 values. Why 10 values? We have 10 different classes because like it's ranging from 0 to 9. So we have 10 different classes. Which particular class, which whether this image corresponds to 3 or not, something like that. Okay. So if you know about the logistic regression, it will always consider all the classes into a binary format. Binary format means, like suppose it will detect it this particular image whether 3 not 3. Similar to that 1 not 1, 2 not 2, something like that. And in that format it will always give the prediction. Like suppose for whichever particular predictions the confidence will be the maximum, we will predict that class. This is the overall funda of logistic regression. Okay, and we definitely need to know the complete working principle of logistic regression, because we are going to use this logistic regression. And if we are mentioning this kind of thing in our CVs, then interviewer will ask very deeper questions on the logistic regression use case, and definitely the working principle of logistic regression also. Like because logistic regression has a very unique kind of loss function, which is something like minus of y into log of y predicted, and minus of 1 minus y into log of 1 minus y predicted. So this kind of loss function will be there. How exactly we have derived this kind of loss function, and how exactly this loss function is helping us to find the global minima in the case, and solving the like this kind of problem. Okay, so we are going to discuss all about this. Definitely the logistic regression will not be we are not going to discuss in this particular course, because we are building models, so it is pre known that you might be knowing the logistic regression working principle. So we are definitely going to use the scikit-learn, so that's why we are not going to discuss the complete logistic regression working principle here. Okay, so but definitely learn this particular beautiful section. Like we already know that weight transpose into input plus bias corresponds to output. And we definitely know that our output is nothing but the 10 cross 1 matrix. Why 10 cross 1 matrix? Because we have 10 predictions, 10 classes, 10 categories, right? And as to validate this kind of matrix multiplication process, bias is a kind of thing that will have the same matrix dimensions, right? So it will also be having 10 cross 1 matrix dimension. Right. And this product should also be having 10 cross 1 dimension only. Then only the addition will be possible. Okay. We know that X is nothing but 1 cross 784 matrix. Or 784 cross 1. Okay. And the weight matrix can be 1 cross 10. Right? This is weight transpose. Please remember, this is weight transpose. Okay. If this is weight transpose, let's remove the unnecessary things. Okay. We know that X is this 1 cross 784 cross 1 matrix. Okay. Now, if we try to multiply it with 1 cross 10, will the multiplication will be possible? Definitely not. Right? So how many things will be required? How many things will be required? What exactly will be the case? So if we make weight matrix as 784 cross 10, then what will be the weight transpose? In that case, the weight transpose would be 10 cross 784. Okay. And when we will multiply weight transpose with X, which is nothing but X is nothing but 784 cross 1 matrix, and weight transpose is nothing but 10 cross 784. So weight transpose into X will produce 10 cross 784 multiplied with 784 cross 1. So in that case, what will be the dimension of the resultant matrix, which will be 10 cross 1. So that's how our matrix multiplication format will look like. And the total number of parameters that a model should learn. This is very important question for machine learning interviews. Okay. So now suppose 10 cross 784 is the weight matrix. Our weight matrix is 784 cross 10. How many elements would be there? 7840, right? 784 into 10. These many elements model should learn. Definitely not. There should be some addition of bias, which is 10 cross 1, 10 cross 1. So that's why total learnable parameters here would be 7850. So these are the total number of learnable parameters in a logistic regression model when we will be building handwritten digit recognition classification model. So please remember this kind of calculation and always try to formulate your predictions in the form of weight transpose into X plus bias, which will be giving you the output. So let's quickly do the overview what we are going to do in this particular course, in this particular video. Kaggle data. We will be using the Kaggle data, which is nothing but the structured format of the MNIST dataset. Structured format means it will be a kind of in the CSV format. Okay, CSV format dataset. Once that will be loaded in our Python environment, we will do the exploratory data analysis, like how many classes, how many samples corresponds to one class, something like that. There should be some kind of balance in the data set. Every class should have equal number of samples so that our model should not be biased towards one of the class. It can be a possibility, right? So that's why we will do the EDA. Once that is done, we will normalize the data that we discussed by dividing 250 by dividing it with the value of 255. Once that is done, once the data normalization will be done, we will be forming the model. Once the model formation is done, we will be evaluating the model. Okay. Once the evaluation is giving us some kind of perfect value, like suppose greater than 90% is the case. If our model is giving me more than 90% of accuracy, we will be satisfied. But this thing needs to be made sure before the model development. Okay. If our model is giving me more than 90% of accuracy, I will be satisfied. Okay. So once that is done, we will be saving our model so that it can be reused later as well. We don't need to develop the model again and again every time we will be using our code. So that's why we will be saving the trained model. Means we will be storing the weight and bias values definitely. Okay. So we are going to save these models. Once this is saved, we will show you how to load the model. Okay, because you can directly ship or you can directly send the saved file to any of your friends or any of your like clients or customers. They can definitely load that particular model and then run it, run that model on their end. You don't be bothering. You will not be bothered after creating this model file. Okay, once model loading will be done, we will be developing a function where we will be using a secret data. We will see the complete pipeline. Suppose we have a folder of images, how exactly we will be using those images to find the predictions, which particular digit is present on those images. Okay, so we are going to discuss all these things in our blog, and So once that is done, so please, we definitely are going to use few of the libraries which are nothing but Matplotlib, and definitely Seaborn is also required. Seaborn is for, we will be developing a confusion matrix on that particular uh, predictions. So that's why we will be using Seaborn to give you some kind of better visualization also. And after that, we will be using Pandas to read the CSV files that we have in the data format. Pandas, we will be using Numpy also. And as we have secret data in the form of images, we definitely need to read those images. And for that, we will be using computer vision library, CV2. Okay. So these are the libraries that we will be needing. And once that is done, and definitely to, a code environment will be VS Code. And please remember that I always recommend, or I always like advise learners to use some kind of Python virtual environment, because it will not disturb your global environment or maybe some existing environment, because your projects might be needing some kind of different versions of these library. And in the case of, if you will try to update it, some of the codes that you were using earlier and they were using or developed with the previous versions of these libraries, it might be a kind of possibility that uh, if you will try to update the libraries, those codes will stop working. So in that case, I always recommend to use a new virtual environment where we will be building, or we will be like installing these libraries from scratch. Any confusion? So let's start the coding. So we will be going directly on the first. We need the data definitely, right? So let's go and search the Kaggle data we have. So if you will try to find, this is the data that we have, MNIST data in CSV format. It will have MNIST train.csv and MNIST test.csv. So once you will download it from this, it will ask you to create a like profile on this particular platform, Kaggle. Then only you can download the data. Once the data will be downloaded, we will be using the VS Code. Okay, so this is our VS Code. You will form two different folders. Like suppose you already have extracted, we already have extracted the data in the MNIST data folder, which is MNIST test.csv, MNIST train.csv. Okay, MNIST test and train are the two different CSV files, and this is the secret file we have. Like suppose this is 5, this is 2, this is 1, this is 7, and this is 9, this is 7 also. So we will be passing these kind of files into our model and then quickly see what kind of prediction it will give. Okay, so what exactly we need to do now? Once we have the VS Code ready, we have the data we have developed, what we will do? So as we asked you, uh, we will be creating a Python virtual environment. For that, you can definitely use Python minus this command. Like suppose our objective is virtual environment, OCR, optical character recognition, right? So let's create it. Yes, it's being created. Now, what exactly we need to do? So currently we have just created the virtual environment. We haven't activated the virtual environment. So this particular thing definitely needs our attention here. So so we need to activate the environment which we have just created. For this, we can definitely use we can use this command. This is VNB OCR. We have now entered into the virtual environment that we have just created. Any confusion? So no. So one thing is, like, if you don't know about these commands, you can definitely go towards the machine learning project code, which is our GitHub repository, and you can definitely find these commands. This is the creation of the virtual environment. This is the activation of the virtual environment. Once that is done, we will be using this upgradation of pip. Okay, let's do that. See, so pip got installed or got updated as well. So now we are good to go. But before that, we will be going to use the Jupyter notebook. Okay, so let's create a. So first we need to install the Jupyter notebook as well. So for that, we can definitely use pip3 install notebook. So this will take some time, but see, it will be installed in just a while. Yes, it is installed now. So what after that, we will be using Jupyter notebook to write our codes now. So it will open a link, a localhost link, which is directly referring to your VS Code only. So this particular folder is being loaded here. Okay. Now this loaded folder can be directly used to create a notebook file. So I used new command, and you can also use. So now we will be using a file where we will be directly coding. We need to select the kernel, which is Python 3 kernel, I guess, and for everyone it will be the same. Let's name it as ocr.ipyonb. Naming convention is very much required in the professional coding experience. So definitely do not use any of the variables like a, b, c, d like that. Okay. So we will be going to name the variables very carefully because that itself explains the complete code. Now, what exactly is the requirement? We need to read the data set that we have. We have these kind of CSV files, right? We have these CSV files, but don't have that library which actually reads these files. So what we will do, we will first install the Pandas library to read these. Okay. So you can run it by using this, or you can definitely use the shift enter command also. So it will install the Pandas library. And once that is done, so let's use successfully install the Numpy and Pandas. It already installed the Numpy and Pandas. Okay. So once that is done, let's import the Pandas library. Pandas as PD. Now the new name of, we definitely do not want to use the Pandas, which is a big name, right? So let's use the short form of Pandas, which is PD. Shift enter, it will load the Pandas in our environment in this code, right? So it has loaded the Pandas library. So what we need to do now, we need to use the or read those kind of CSV files that we have. For that, the command is pd.read CSV. Okay, and we need to provide the path of those files. Like suppose this is the file, copy relative path, and we can directly go to there, and let's load the test df as well. pd.read CSV, the same thing, but in case of train it is test. So yes, the files are being read. So let's quickly check what are the things that are present in these files. Okay, train df dot shape, or maybe let's print yes shape, and also the test df shape. 6,785, 10,785. So what does that mean? Like 785, we learned that 784 numbers would be there. Why 785? So let's try to print why 785. Train df dot head. Head prints the first like number of first 5 elements. Head 5 will be printing the first 5 elements directly, and we will be seeing which particular columns are present in our data set. Okay, like print shift and row label. Label is one particular column which corresponds to the seven other numbers are 784. One column is corresponding to the label. Label represents this particular image corresponds to suppose 5. Then in that case, there should be a column. Definitely, there should be a column of label as well. Then only we will be able to completely say that the data is supervised. Okay. So now, once that is done, what exactly we need to do? We now know that the first corresponding column is for the labels, and the rest of the columns are data. So let's convert our data into the array format. Train array is equal to, we will be using NumPy here. So NumPy is already installed, but we haven't imported NumPy as of now. So let's import the NumPy library first. NumPy as np. NumPy is being loaded. So what we will do, we will convert our data frame into array format, because handling array is very much easy. Handling data frame is also easy, but array is something like we can directly handle to truncate the different arrays in the different shapes which we wanted. Okay, so what we will do, np dot array train df, and then same thing we will do with the test array as well. Now it is being done. So we can definitely see that the labels are shuffled, but to make sure that we are not doing something wrong, let's reshuffle the data as well. Because some of the times the data stored is something like all the 0 labels will be like stacked together, all the 1 labels would be stacked together. So in that case, what will happen, that model will learn in a sequence wise manner only. Like 0 should be coming all together, 1 should be coming all together, something like that. We don't definitely do not want something like that. So we will shuffle our data. Yes. So let's separate the labels now, as we do not want like labels to be always attached with the data. So let's use X train and Y train. Let's separate X train and Y train. We know that from first row, first column till the last column, data is present. And for the first column, we have labels. Like same will be done with the test data also. Definitely not train array. This should be test array. No, definitely not one here. This should be zero, right? I guess everything is correct. So let's check their shape as well, just to make sure that everything is right. There should be one label corresponding to uh, each data sample. So the first dimension, the number of samples, which shows the number of samples, should be equal in X train and Y train. Then only our data set is correct. Otherwise, the data sample will be wrong. So we need to check what exactly went wrong in that case. See, 784, 28 cross 28 images in the form of array, and then we have 60,000 of train samples. So 60,000 labels are also there. 10,000 samples for the test and 10,000 corresponding true labels are also there. So which is very perfect. Our data don't have any kind of problem. But one thing is like we definitely do not want uh, we so let's first do the first quickly check few of the images whether their labels are correct or not. We definitely do not know now, right? So for that we will be using the Matplotlib library, but we don't have Matplotlib library, right? So we can install. So now the Matplotlib library is being installed there. Okay. So let's import the Matplotlib, because Matplotlib library is to for the data visualization, and we are going to visualize our data set here. Perfect. So the loading is successful, means the installation went successful, and it is also saying that successfully installed Matplotlib 3.8.2 version. Okay. So now what exactly we need to do? We need to quickly draw or like plot some of the labels and corresponding images as well. So what we will do, we will draw the suppose first five images. Okay. For idx comma data in 8x train, first five data we want, right? With all the columns. So that's why I have written something like this. Enumerate is a function which will give you index values and the corresponding data simultaneously. So what we need to do, plt dot subplot first figure in which five columns are there, in which first column would be this. Why idx plus 1? Because idx will be starting from 0, but in subplot we don't have that flexibility to start from 0. We can definitely we can only start from 1 only. So what exactly we need to draw, or maybe use some kind of im show to draw the data or plot the data, which is image, and image should be in the form of matrix. Matrix which is like so 28 by 28, not 1 cross 784. So what we will need to do, we need to reshape the data, and p dot reshape, which is data. Data is something like it will be giving us one corresponding data row, right? We need to reshape the data in the form of 28 by 28, right? Plt dot title. Title means title would be giving some kind of name. Like suppose we are giving true label for this is %d. and percent. So we can definitely use the y train, x train, and y train we created, right? Y train and corresponding index value. Things are correct, I guess. And p dot reshape data, right? So let's quickly try to plot it. Perfect. Or maybe what we can do, a picture is very much, I guess, clumsy. So let's use this plt dot figure, and here we will use fig size. Fig size is nothing but like we want a very big data in the width form. So that's why we will use 10 cross suppose, or maybe yes, 10 comma 15 wider picture, or maybe let's do 20. Perfect. So see, this is the actual data which is corresponding to 9, which is this is 8, this is 1, this is 8, this is 6. Very perfect, right? The true levels are always going to be perfect only. Now let's check the same thing with the test data also. We can definitely do that. We need to just change the x train to x test and here y test, right? Yes. See, in the test data also, the labels are perfectly matched. 0, 6, this is 0, this is 3, and this is 7. Very perfect. Now, what exactly we need to do? We need to, so we did the EDA, exploratory data analysis. We check the labels which are very correct. Our data is also correct. So let's check the distribution of the data. For every class, there should be some equal number of samples. Otherwise, our models will be biased towards those classes for which the data number of data samples is very huge. So for that, what we can do, we can definitely use the Matplotlib for the same thing. plt.figure. Here we will be using fig size definitely, because earlier we saw that it can be a kind of problem for us. Now what we will do, we have two data sets, right? Train data and test data. We will be using plotting everything side by side. One comma for one image, there are two columns. For the two columns, we have first image as our train data, and in that we will be showing plt dot histplot. Histogram is the kind of plot we are going to use or to check how many samples. Histogram plot will show us the number of samples present in each of the classes. Okay, and for that we will be using y train, right? Y train. And let's first look into this Y train, and we will be setting the title also, plt.title, which is nothing but like training data, sample distribution. And we need to create the subsample for the, subplot for the test data as well. So Y test, and this needs to be changed to 2, right? Because in the first image, 2 columns, the second column corresponds to the Y test, where we are plotting the histogram plot of Y test. And this should be testing, not training. Testing data sample distribution. And let's do plt dot show. See, so this is very wide, 20 by 20. So let's make it 5 by 20. First column, sorry, 5 by 20. So I guess the second column corresponds to the width, and then first column corresponds to the length. So in that case, let's do this. Let's make it what I say 20, and this as 10. See, so we can definitely read it like for the 0 we have somewhat around here, for 1 we have here. So but still the data does not look very aesthetically good. So we can definitely do one thing. We can like uh, use this technique. Bins 20 will ensure that there are 20 bins should be there in the 10 for the 10 samples. One will be blue, one will be white, one will be blue, one will be white, something like that. So if you will count the total number of bins in this particular image, there will be 20 bins in the range of 0 to 10. Okay. So that's why now we can clearly understand the number of samples present for each of the classes. Like for the 0, we have around suppose 5 5800 or something like that. For the one we have more than 6500 and something like that. So data seems to be pretty much balanced. We don't have too much variations from the trained data and the test data. So definitely we do not want any kind of technique to like crop the data samples, or do not use those samples, or like remove some of the samples from one of the class. We definitely do not want, right? So that's why we will be moving ahead directly. Let's make it more good. Yes, right. So now what we will do, so once that is done, so we still need to normalize the data. Earlier we didn't normalize the data, or is it? No, we didn't normalize the data. So what we need to do, we need to normalize the data. So x train will be equal to x train divided by 255, right? And the same thing will happen with the x test. X test. So let's do one thing, or maybe yes, let's do this thing, because this will be very much easier for you to understand what exactly we are doing. So let's check the first sample here. When you will try to put the press and shift enter, so we have values like see 212, 253, 186, these kind of value. So that's why we definitely do not want this kind of thing. What we will do, x train equal to x train, or let's name it differently, x train normalized. Okay, x train uh, x train divided by 255, and let's print the x train normalized, the first sample of this. Now see the values. That is already normalized now. Very perfect. We definitely do not need to see the things like uh, the data is normalized now. This is very nice for us. So we will do the same thing with the test data also. X test normalized is nothing but dividing the X test array by 255. Perfect. So we have the data now ready with us. We have already normalized everything. Any confusion till this point? So you can definitely ask. And once this is done, we can definitely do model formation. And for that, we require Scikit-learn to be installed. So for that, we will use pip3 install Scikit-learn. Perfect. It is being installed. So let's import our logistic regression function, which we are going to build here. Train here, sorry. From from Scikit-learn. Scikit-learn is written as sklearn dot linear model, because once again, linear model import logistic regression, right? We wanted logistic regression only. So we will be using model is equal to logistic regression with few commands. Max iteration. Max iter will represent how many iterations our model should look before converging. It can definitely converge way beyond before 1000 iterations, but definitely not go beyond 1000 iterations, which will be too much for logistic regression to go. So we will be definitely using max iteration, and also we are going to use fit intercept. Fit intercept means here if we do not say that fit intercept would be true, so then it will definitely not learn the bias values in that case. So we want our model to learn the bias values also, because we definitely can't say that bias will always be zero, right? So what we will do, we will use this model and then fit our data. Model dot fit x train normalized, right? Not x train, and corresponding labels will be y train. So let's run it. It will take some time, but so let's till it is finding the perfect values of those parameters. What we can do? So let's start to use some kind of method by using which uh, we will be saving this model into a file. Okay, so but that requires another for library, which is install. So let's wait. So because we don't have the pickle library, and once this pickle library will be installed, what we will be doing, we will be making a file name, suppose, in which we wanted to store this saved or trained model. So that file name can be like, suppose, logistic. Please give a meaningful name, otherwise you will forget the name of this file. Logistic regression OCR, but in the form of pickle. Okay, because we are going to use this library to store our model. Model means like the weight, trained weight values and bias values in the pickle format. Okay, once that is done, you need to open the file. File will be open. We can definitely use the Python open file. Now our model is already trained. We will be quickly doing the evaluation process one also. So open this file name, but with the point with the view of writing something in it, right? So that's why WB corresponds to write. Now we will use pickle.dump model into the file, and then we need to close the file. But before that, let's install this pickle file. uh, Sorry, I think it's pickle. Couldn't find the pickle version. Is it? So let's see why exactly it is saying this error. We use both the things, pick3 install pickle. It is also not working, right? Pickle4 is the command, not pickle, right? So let's use this command. Perfect. It has started installing the pickle library. So once that is done, we can definitely use this code. We are making a file in which, and opening the file with the view of writing in it. We have written the model inside this open file, and then after the model is written on that file, we are closing that file. Sorry, the name, I did a mistake. We haven't defined the names because we need to import the library also. Import pickle. Now it will be done. So see, so we have already saved these files, and how exactly you will be sure that this file got saved? When you will go into this. So see, there is a new file here. You can definitely see the same file here also. Logistic regression OCR.pickle. You definitely can't see the file, but yes, this file is being made here. So, but before that, let's first do one additional thing, which is like evaluating the performance of our trained model, which is very important. From sklearn dot scikit-learn also provide the metrics for us. Import confusion matrix and accuracy score. So these two things will be very much sufficient for us. Okay. So let's first check the accuracy. What exactly the accuracy we got? Trained accuracy is accuracy score. So, but before that, we wanted some kind of array in which we will be storing all the predicted values for the training and testing, right? So let's make a new cell and then store train prediction and test prediction is equal to model dot predict x train normalized and model dot predict x test normalized. Yes, it's done. Now check the training accuracy. For training accuracy, accuracy score requires two different parameters, which is y train and y train prediction also, because we want to check the difference between y training the actual samples and the predicted samples. Okay, and also test accuracy is the same thing, but y test and test prediction. Print training accuracy is round train accuracy into 100 up to 4 positions of decimal places, suppose. And the same thing with test accuracy, round test ACC. Why 100? Because the accuracy numbers that this library will give in the will be in the range of 0 to 1, and we want in the percentage range. So that's why it is we are multiplying it with the 100. So let's check. See, our training performance is 93.866%, and then testing accuracy is 92.58%, which is very much this is satisfying our needs. We wanted our model to give us some kind of predictions more than 90% with the more than 90% of accuracy, so which is very much in line. We can definitely try tune these kind of models, try out many various different parameters being involved. We can definitely try to change the solver that are being involved in this case. We can definitely change the C values, which represents the strength of regularization. We can definitely apply some kind of penalty like L1 and L2 regularization to improve the performance of the model, definitely. But that is again a kind of separate task which requires a complete video, right? So that's why for this particular video we are okay with the testing accuracy. But before that, let's quickly use some kind of visualization technique to plot the confusion matrix. And confusion matrix is the mother of all the evaluation matrices that we have, right? So that's why what we will do, we will quickly extract the confusion matrix. Confusion matrix will take the test. We will plot it for test only, and which is sorry test prediction, right? Yes, confusion matrix will be done, but we will be requiring Seaborn library to plot it, right? So let's install the Seaborn. Perfect. Seaborn is installed. We will be importing Seaborn the same. Otherwise, it will be creating the same error that we did with the pickle as SNS. Okay, so it is being installed here. Seaborn is installed. We will be creating an heat map. Heat map is, I will quickly convey you what is the heat map. So SNS dot heat map confusion matrix. We have done the calculation for confusion matrix. We definitely want our heat map to be annotated already, okay, and not equal to true. I will quickly explain these things. C map, we require the color mapping we require is something like blues in the blue color, okay. Once C map is done, we require, okay, so that's it, I guess. And we want some kind of figure in which we want to plot it. plt dot figure. Fig size would be, like, make it a big fig, 20 by 20, suppose. Okay, let's label the axis as well, because the axis label is required here. X-axis is predicted values and y-axis is actual values. plt dot show. Perfect. Let's see. X label. So this has become very bigger. So let's make it 10 only. Again doing the same thing. 20, 10. Perfect. Right. See, values are not so easily readable, right? So that's why what exactly we are going to use. we are going to use the formatting thing where we will be plotting the or using this kind of technique to represent these numbers into a four uh, digit numbers. Now the things are readable. See. So what exactly it represents? The confusion matrix for suppose any column like this column 3. So we have 921 samples which are actually 3 and model also predicted 3. But we also have 35 such samples which are predicted as 3 but they were as 5 because 5 and 3 somewhere look around same, right? So we have 35 such samples which were actually 5 but our model predicted them as 3. So there are 24 such samples which were actually 7 but our model predicted it as 2. And there may be some kind of confusion with 0 and 9 also. So let's quickly check how many samples are there. 0 and 9. So there, like suppose this 9 is the actual class and model predicted 0. There are 9 such samples. There can be confusion with 7 and 2, right? It can be a possibility. 7 and 2, yes. And here also like see 2 with 8. There are 33 such samples which were actually 2, but our model predicted 8. So these are definitely the wrong values. We definitely want all the values should be present in the diagonal format. Okay, but that is definitely not true because otherwise we will be achieving the 100% accuracy. And by tuning some of the parameters, we can definitely reach more than 96% of accuracy in this case, right? So, but our purpose is solved. We have plotted the confusion matrix. Let's move towards loading this particular function which we have created. And once this is loaded, what exactly we need to do? We need to use the loaded model to predict the classes on the secret data that we have. Okay, but for that we require a library which is OpenCV3 install. Yeah, successfully installed. Let's import this library, import CV2. So let's create a function first. Okay, function would be like we will be like predict digit on image, and it requires file path and which model we are going to use and what would be the size of the model, or maybe size is the fix which is something at around, let's use the size also. Size is that a model our model requires is something like 28 by 28. But before that we need to load this model also which we have created, logistic regression pickle. Okay, so what we will be going to use, we have to create a file where we will be opening that same file which we have created, but with the view of reading the things that are present here, right? Not writing something. Once that is done, what we are going to use pickle dot load and model loaded. No, sorry. So we need to use the file, right? And this file, whatever data that is present in that file is being loaded here, and that will be given into the variable name named model loaded. And once that is done, we need to close the file. A question to you, why do we need to always close the file? Let's run it. Yes, model loaded is done. So we have already loaded the model, which so you can directly send these files to your like friends. They can directly use these 3 lines to load your model, which you have already trained for them. Right? Very perfect. Now we will be using this model loaded here in this case. Okay, model is equal to, let's make it model loaded. Now we are going to use the image or read the image from the this file path. For that we will be using this CV2 library that we have just imported, right? We will be using imread function from this library cv2.imread file path. Okay, now so to give you a more gist, let's first do everything in this in the cells and then we will create a new function around it. Okay, see, we definitely have the secret data. Let's find the let's use its relative path and then load it here. Okay. Sorry. One. Okay. So now what exactly we require? Let's check the shape of the loaded image that we have just read. There are three channels. We definitely do not want all the three channels, right? So that's why we need to convert this image into a form where it will be a gray image, not the colored RGB images. So for that, what exactly we need to do? We need to make img2 as cv2 dot convert color and img cv2 dot uh, bg this bgr this also bgr no color dot bg cv2 dot yes color bgr to gray because we want to convert it into a gray format, right? So once that is done, let's check the image2.safe also so that we will be sure whether it is converted into a, yes, it is getting converted into a 28 by 28 matrix. Perfect. So what exactly we are going to do? We are going to read the file path, but after that we need to convert it into a gray format. Okay. Once that is done, still it can't be used, right? So we need to convert it np dot reshape image 2 in the form of 1 comma 784, right? Any confusion? Because we are passing the model 1 comma 784 numbers, not 28 by 28 images, right? That's perfect. So after that, this is still not able to pass it through the model, right? Why so? Because we need to normalize the data, which is like img4 is equal to img3 divided by 255. Perfect. So once that is done, we can definitely use the this particular array to pass it through the model and then get the prediction. Prediction would be model dot predict and please remember we haven't used this size. What is the use of this size? Sometimes it might be a possibility that our red image will not be in the format of 28 by 28, but our model requires in the format of 28 by 28 only. So in that case, what exactly we will be doing? cv2 dot resize img2 in the form of size. Whatever, like suppose our model is 224 by 224. So in that case, our model will be first resized in the form of 28 by 28, and then will only our this reshaping will be done, right? Otherwise, it will be an error because 224 cross 224 never be converted into 1 cross 784. So now we will be using img4 here to get the prediction and return the prediction. Perfect. So let's we will be using some kind of what I will say plt dot figure just to check whether everything is right or not. So let's plt dot figure and plt dot let's first do the prediction of prediction is equal to predict digit on image. We need to pass the model path. Sorry, model path is sorry the file path. Let's choose anyone. This seems to be complicated. It can be 9 or 7 also. So let's select the relative path for that. Definitely passed as string only. Okay. And model and the default values is already model loaded. We already have loaded the model loaded as this particular file, and then size is already done. So predict is something like already done. Now what exactly we need to do? plt dot we would be requiring to read the image also. cv2 dot im read this file and plt dot im show this image and plt dot title prediction for this image which is red, and plt.show. It will plot a beautiful image for us. The same image which we have in the secret folder, it will be loaded here and then give the prediction. So title is something like, sorry, title should not be used something like this. So we can are going to use this percent %d. Okay. Prediction for this image is 7. So our model learned better in that case. So which is very good for us. And it is not 9. We can definitely check different images as well. Like suppose this one. This is 9. Copy the relative path. Change the relative path here. Let's make it a file name. And replace all these things by file name. Perfect. Our model predicted it as a 9. Perfect. So we can definitely try to write something from our own, convert it into a 20 by 8 by 28 image, and then pass it through this function, which is already needing the loaded this model. And once we will pass it into the format of 1 cross 784 matrix, it will normalize that image and then pass it through the uh, trained model and then give the prediction. Now it is giving this prediction. We can definitely try some another image as well. 0 is corresponding to 7. Let's try the 5, whether our model learned something or not. Let's change it to 5. Let's see. Our model learned predicted 5 on this image, which is very good, right? So model is done. You can definitely like send this model over the cloud and then use the deployment technique directly to serve many different customers or any users, friends to play with this model, which is very good, right? So we have already done the coding part. The complete coding is done. So let's quickly do the possible interview questions on that. Because if you are going to write the this particular project in your CVs, so it might be a kind of very probable thing that they will ask you to like answer few of the very relevant questions on this topic. And in if you have some kind of experience of any kind of interview, people generally ask questions from your CVs only. If you are mentioning one of the project, then you must be very clear about that project and must be answerable to all the questions that you have. Okay, so let's do one thing. So uh, answer these kind of questions. What is logistic regression? So logistic regression, as I already told you, that they will be asking first question about the algorithm, their mathematical details, like how exactly logistic regression works, or maybe what is the inline mathematics involved here, what is the logit function, what is the role of sigmoid activation function here, and all these kind of things. You need to answer, or you need to understand the logistic regression, and it is available on the blog as well. Define the cost function for logistic regression. It is the cost function is based on the maximum likelihood principle, and we already discussed that y into log of y predicted minus of 1 minus y into log of 1 minus y predicted. So this kind of loss function is very unique for logistic regression, and you should know the working principle of all these kind of things. Why logistic regression? What are the benefits of using this model? So logistic regression, because it is a linear model, it is computationally very cheap, and because traffic violators will not wait for you to like capture the image and then give the prediction and then send the challan over their homes. Definitely not, right? So this is something like we wanted some kind of very fast model in that case, and that's why we are using logistic regression for that. What are the benefits of using this model? As we already discussed, what EDA did you perform on the data set? We checked the distribution of samples for different classes. We plotted few of the samples corresponding to their true labels. Labeling was perfect. We actually cross-verified it. These are the EDA techniques that we did. We also normalized the data. Suppose my image is not 28 by 28, then how you will make the predictions using logistic regression model? This is a very perfect use case. We just saw that if our model is not 28 by 28, we will first need to resize it, cv2.resize. Otherwise, there is no such possibility to that our model will give the prediction. We first need to resize it into our required format. Then only this model will be giving us the predictions. How many parameters are there to learn in this model? As we discussed, 7850, and how exactly 784 cross 10 in the weight matrix and 1 cross 10 in the bias matrix. There will be 7850 parameters. So that's it for the today's project, and I hope you have learned a lot from this project and developed something new. I wish to see you in the upcoming classes of live machine learning course on our algorithm platform, for which the enrollment is currently going on, and probably in few of the weeks we will be closing the enrollment and starting the new batch. Thanks a lot.